Welcome everyone to my Tom talk on the M5 forecasting accuracy competition on Kaggle. The topic of it was to look at estimating unit sales for Walmart retail goods. I'm a recent graduate of the UBC Master of Data Science program. Again, my name is Thomas Pinn. Unless you don't like my presentation, then my name is actually Matt Emery. So, introduction. So I'd like to introduce you to Spyro Makridakis. He's a professor in Cyprus. I'm sure everyone's read his fabulous published articles, which include forecasting methods and applications, forecasting and planning and evaluation, average forecasting, some empirical results, accuracy of forecasting and empirical investigation, and he was dubbed one of the fathers of forecasting. So everyone at this point must be wondering, why did I introduce him? And the reason is the Makridakis competition, or M competition, is an open series of competitions organized by him and his team. And it was here to help evaluate and compare the accuracies of different forecasting methods. So the first one was in 1982, and they've been here for once every 10 years. However, with 2018, it began to really blow up because a gentleman from Uber won the competition. And since then, this M type of competition has gained like a lot of like notoriety and a couple more corporate sponsors. So onwards to the fifth competition, which will be the talking point of this presentation. There was two versions this time around. There was the uncertainty and accuracy. However, for the purpose of this presentation and meetup, we're just going to be focusing on the accuracy part of it. So an overview of the competition was the prize pool was $50,000 for just the accuracy part of it. So there was 42,840 time series. It was Walmart hierarchy data. The dates ranged from the dates of like sales data ranged from January 1st, 2019, 2011 to June 6th, June 19th, 2016. So what exactly is hierarchical data? Hierarchical data is sort of like builds up into a hierarchy where you have three different states that was given. So there was 4 stores in California. There was 3 stores in Texas and 3 in Wisconsin. And then in each given store, there was categories such as hobby, foods, household items. And then it was broken down into department like hobby 1, hobby 2, or food 1 to food 3. And then in each department, there's a bunch of like products and different SKUs.
So clearly there are like more Walmarts in those states and more states in the United States. Do you know like why these?
I'm going to be honest, I don't think there was like a reason why they did. I think they just had to like pick a point to cut. And I think at that point when you can begin to do like 40,000 time series, it becomes like more manageable. Also, like these files were like semi small enough that you could probably run a lot of the models without having to hook it up to like a GPU. So that's like sort of my rationale behind it. But other than that, I'm unsure. Maybe it just also gives you like a good range.
There also must be some kind of like competitive privacy concern from Walmart.
Yeah, for sure. Like everything's like anonymized. Like everything just has like, you know, like hobby item 1. No one really knows exactly what that is, right? And I'm sure it's like.
Sorry, just on that, is hobby item 1 going to be the same regardless of whether it's in Texas 2 or Wisconsin 3?
Yes.
Okay, cool.
For sure. So once you signed into the competition, they provided you with 4 files like a calendar, a price, a sample submission, and then the important sales training validation. So in the calendar CSV, it would indicate the week ID that it was given, the day of the week, the year, and then the more important thing to notice is like the day ID, which corresponds to the sales data and how much a given SKU is selling on which day. And then additionally, they provided like information like if there was like an event that day. So like you would expect like to see like a spike in sales with like Easter or like the NBA finals, theoretically, right? The next one is the sales price. So items can fluctuate in price from week to week depending on sales and so on. So in like a given sales week, like the price may be discounted or be full price at another point. The next one was the sample submission, which I'll cover a little bit more in depth after. And then there's the all-important sales training data. So it would, in this CSV, they provided like the ID, like the item ID, and then like the department and so on and so forth for you to be able to categorize it. And then essentially what this means is at the very first day that I mentioned a few slides back, I think it was January 29th, 2011, they sold 0 of this hobby item. And then on the very last day, they sold 1 of that. It doesn't take into, this is just unit sales, not unit sales times price. So the objective for the competition was to provide a forecast of sales data. So you were trying to predict 28 days into advance, but times 4,000 or 42,000 or so. So essentially the way that you would want to think about it is they provided you this blue line for training data, and then you're trying to make a prediction green line that closely resembles the validation set, which was hidden and no one had like access to at the time.
Can I ask, just going back to the data provided,
yes.
Do I see that there's no stock data, where in particular it's my understanding that stock outs are like an important factor or can be an important factor in these situations where like if the price is low and people want to buy it but there's none on the shelf, then it doesn't sell, right?
No, for sure. I was going to cover that in sort of the issues like coming up ahead where it doesn't tell you when there is a stock out. So you could like feasibly predict that you would have X amount of sales and you just happen to be at like a stock out that month, right? So going forward, so in the sample submission, they provided you with like an F1 for your first point forecast, and you had to provide that for every item up to day 28. However, with everyone submitting these types of sheets / like matrices, how do you combine it down into one constant number so we can compare everyone? So traditionally you would want to use either like the mean absolute error or the root mean squared error. And essentially what that means is the blue dots represent the actual sales for that day. And then the line, this regression line, represents your prediction. And then the distance between this point and your regression one gets calculated, and you're trying to minimize the distance. So what did the M5 competition use for this? They used the weighted row-wise root mean squared error, scaled square error. And there's a couple reasons on why they kind of chose to use this for the point forecast was essentially the reason why they chose to do with like a scaled error is you can compare the different products regardless of how many they're selling per month. So you can compare like units that like SKUs that are selling like hundreds a day versus like ones that might be only selling a few times a week. Additionally, some people may be asking why not use like a MAPE as instead of like the root squared error mean. And the reason why you can't use MAPE is because there's a lot of units that don't sell in a given week. And if a unit has like an actual value is equal to 0, that really messes with the math for MAPE. So that one wasn't really an option. And then at the end of it, they decided to introduce like a weighting to it. And I think the best way for me to show you what the weights are and explain it to you is with a short, small example. And this is directly from their competition guide. So imagine you have two products, product A, which has $10 in sales, and product B, which has $12 in sales. So these are the only two products in it. So one has like an MR or RMSSE of 0.8 and the other has one of 0.7. So if you took the combined ones, it's 0.77. However, because product B is selling more, then it becomes like a higher weight and more important to it, to the store sales in their mind. So it gets weighted properly. So you change this 0.77 down to 0.758. And I believe the reason why they did this was so you can compare like a high price, low volume to like a low price, high volume. So just to do like a little bit of EDA so everyone like understands what's kind of going on with it. So this is just 4 units over time. So imagine, so I just took 3 out of the 42,000 of them, for example, but you can see how sometimes some items don't sell very well in a given month. And I think this blue one down here with all, like you're not selling any of them, this is like truly one of the reasons why you can't use MAPE as a scoring mechanism for it. I also kind of want you guys to keep this in mind when we go forward, because there's like another part of the solution that's really interesting as part of it.
Sorry, can I back you up?
Yeah.
Like one to the evaluation metric here.
Yes.
So I definitely understand the idea that we would weight things by like their aggregate revenues, right? Because it's like that's like a measure of importance. So that works for me. What was the scaling? What were we scaling by?
Is it this one here?
No, I guess back another slide, I guess, because so root mean squared error. Sure, I've got that. Can you give me an intuition? What's the scaling?
The scaling part of it?
Yeah.
I believe it's this bit here, but like when we start to get into formulas, this is where I begin to hit my like weakness a little bit.
Yeah, it's like there's enough random symbols on this.
Yeah.
It's not immediately obvious to me what's going on.
I believe it's the reason why they wanted to sort of scale the errors is to make sure, I guess, like, because maybe it's because you're using like the distance between points, and if there's like a huge distance you don't want it to, or for example, if you're like selling 1 versus like 100, like if your error is off by like 20 in the 100 scenario, then it becomes like a real issue for it. That's just my intuition on that one, but like I'm more than open to hear what people think about it.
They're doing something funny with the time indices there. You see how on the bottom it's like from 2 to n, but on the top it's from n+1 to n+h. H looks like a free choice that they may have picked. Well, okay, so they do something to compute this like scaled root mean squared error, and then they weight things by aggregate revenue, which makes sense. Okay.
Well, H seems to be
horizon. So 1 to 28. Sorry, Yves.
That's exactly what I was going to say.
Oh, sorry, my bad.
So H equals 28?
At time 28. So like, because we know that it's way harder to do 28 days out than it is to do like 1 day out. I assume that's why they scale it like that.
It's also more important. Wow.
Yeah. You want to because you want to avoid stockouts, and that would be the way to do that, right? Is to make sure that everything is there at least like a day in advance. Whereas like 28 days, like who knows?
Okay.
Oh, that makes a lot of sense. I know there's a huge like post in like the discussions that I linked to in my like PowerPoint notes, but like they do talk about it, and there was like a bunch of confusion on why you would want to use this, and then a bunch of people just disregarded it completely. and just they just went with the competition, ignoring like the scoring metric and then whatever it was, right? At least that's what like some of the sentiment I got was.
For the most part, like if you make good predictions, it'll maximize the metric, so we'll be okay. Yeah,
for sure. All right, I'm going to continue on then. So looking at like the rolling average, we can see like rolling average of sales per store. We can see that there's like it's very cyclical in nature. Like we know that in like perhaps like more in like the winter, Black Friday, Christmas time, you have an increase in sales, like a small bump that does us absolutely. And then in the summer, you have less sales, but that does us no good because we're trying to predict like summer sales at this point. And then additionally, we wanted to like quickly look at like a box plot of like the rolling averages just to see like the range that you could potentially be seeing in like within like a store. So like, for example, like California 3 had like the largest mean of like rolling average of sales versus like California 4, which had like the lowest. And then like Wisconsin 2 had the most variation, but that's also because like how much they grew over the last 4 years, right? So some of the challenges that you're going to definitely be facing in this competition was like you're trying to compare different states, stores, categories, and departments, which kind of sometimes creates like an apples to orange comparison, which can be an issue going forward. Additionally, it doesn't take into consideration like weather and disasters. So for example, like maybe like you're not going to be selling like a bunch of like raincoats on like a sunny day, or if it like starts raining, like you have like a bump in umbrella sales. Here's the other big one is like the stock out issue, which we've all talked about. And I think if we'll be seeing with some of the graphs in the past, you can see that there's definitely like a huge gap when there's just nothing there. And then you have to assume like that must be because like a stock out or it's not getting charged properly. Additionally, the last thing it doesn't look at is like blue moon events. So think of like anomalies like Tickle Me Elmo being like really popular one year. It doesn't track that, so we have to just kind of keep that in mind. Of course, like all the data is like anonymous, so you can't like think a way through, right? It's just more about like the peer predictions of it. So a quick side note that I wanted to talk about is like the public versus the private leaderboard. So from the beginning of the competition to May 31st, you were only on the public leaderboard, and the public leaderboard's IADs, like the data that you're testing your 28 forecast on, are from 1914 day to 1941 day. And then that's what you'd be comparing yourself to. And then on May 31st, they closed down the public leaderboard, released that data. And then you did your comparisons, and then you had to use that data as like the next 28 days and then predict even further into the future, which was like day 1942 to 1969, right? And then your deadline was the 23rd and everything was announced on the 30th. So you could use that additional data going forward in the private leaderboard. So some of the technical solutions. So before you begin, you kind of want to have like some sort of baseline to understand your problem and what to do going forward, for example. So someone created like just like an open Kaggle notebook on what your baseline for your model should be going forward. And what they did was they just grouped items by their weekly average, last 28 days for recency, their weekly average for it, and then use that as like a constant for the next 28 days. And you're going to assume like you're going to average out over 4 weeks. So like the idea behind that is if I know that in July I sold 120 avocados on Sunday, there's a good chance that going forward, I'm going to, on average, usually have like 120 avocados being sold the following August. And of course, just Millennial over here have to bring everything back down to the avocado level. So
That's funny. I thought they were pears. Anyway.
I know everyone thought it was. I think I typed in avocado. I'm gonna go with avocado. I think the pick gives it away. So if you keeping this in mind, with this like just simple naive model, like the public score got like a 0.752 when it was being used, and that's what people were kind of using as their baseline score. So whenever someone did a model, if it's not beating that score, then you might as well just go with the simple method going forward. The next idea that we kind of want to talk about is like the sliding window technique. So in machine learning, you want to break your data into testing and training groups, right? However, it doesn't really make sense for you to, if, for example, if you have like day 100, 101, and 102, it doesn't make sense to pluck out day 101, try to predict 101 and continue onwards. So what you do instead is you take chunks of like some sort of chunk, and then you slide it along and predict it against the next one. So using the first place solution as sort of like an example, it's like a really interesting way. What he did was he only did 3 cross validations, and he started on day 1830, did that for 28 days, compared it to CV2, and then trained on CV2, and so on and so forth. It was interesting that he chose to chunk his things into increments of 28 days, which I guess, given the problem of trying to predict 28 days in advance, that makes like a lot of sense. But just choosing 3 in general seemed like an interesting idea, where you're not taking advantage of, like, for example, like last June sales to try to figure it out.
Yeah, like I guess so. Those days, I guess those are at the end of
they're at the very
available data.
Yeah.
Yeah. So the choices he makes depends a lot on what happened in exactly those 84 days.
Exactly.
Yeah.
So he's like thrown out like 2 or 3 years of like historical data, right?
Interesting.
So after he did that, he compared it to the public data set, which was like 1914 to 1941. And once that was released, he incorporated that as his 4th cross-validation, and then continued on to the private data set. So before we begin, I just want to do a quick sidebar on recursion and make sure everyone understands what it means. So recursion is calling from the inside, it's calling the outside from the inside. So it kind of creates like this wonky thing that kind of like folds in on itself, or like fun house mirror idea. And what this kind of means in like programming, for example, is if I wanted to create a function to do a recursive sum, so add the 4 numbers within add these 4 numbers together, what you can do is you can create like a recursive sum function, and then call the function from the outside on the inside to keep passing it along. So what this means in terms of this type of problem and forecasting are, there's 4 total ideas on for how to do it. So one is called like the direct model, where you're creating a new model to predict 1 time step in advance. And then for time step 2, you create model 2 that takes in the past to predict day 2. Then the recursive nature of how to implement like a recursive idea to it is you have one and only one model. You predict 1 time step in advance. You take that prediction and feed it into the same model and predict 2 time steps in advance. The last bit of it is there's like a direct recursive hybrid model, which no one used in their solution, but I just wanted to cover quickly, where you have like a model 1 and you predict 1 time step in advance, and then you have model 2 that takes that prediction and predict 2 time steps in advance. The last one that we kind of want to talk about is LightGBM, and if anyone's familiar with machine learning, I'm sure you know where I'm kind of going with why you would want to pick this. So LightGBM is sort of like it's an ensemble boosting model that takes advantage of many smaller models and learns as it goes down the tree. So the other one is like more XGBoost, which does like a level-wise growth in the different models. But what LightGBM does is it goes down like different leaves and grows like the leaf level. So the reason why you would want to use like LightGBM, for example, is it's like very fast, very efficient. The memory usage is much lower because you only have to learn on the leaf level instead of like the level. It supports two types of learning of like parallel and GPU, and it has the ability to scale for larger data. So from my own experience, LightGBM can be like a very powerful tool. It's worth always considering. However, you sometimes have to be careful that it doesn't like overtrain on your data, right? It's very prone to overfitting, sorry. So if we look at the top 7 solutions, 5 of them used LightGBM, 1 used Deep AR, and 1 did not provide a public solution. So the question that's all in our minds is, why would we use like LightGBM? And the reason is for Konstantin Yakovich. So during the competition, he posted a public notebook called like 3 Shades of Darker Magic, which used the LightGBM in like a very plain, not like a lot to change. And I believe that like this notebook really changed the curvature of this competition, where everyone and their mom wanted to try it out and see how it would do and see if it would get them like the good results, you know, when you have 50,000 on the line, right? So it resulted in like a public score of like 0.4756, and everyone began to like integrate it into their model. So the last thing that people began to also introduce and think about was the setting an objective of Tweedie. So typically you don't have to specify an objective in the LightGBM regressor. However, Tweedie kind of made sense for this type of problem because it made the math really nice. 2, if you look at like a Tweedie distribution and like the display sales in like the first 15 items for the sales and training, it sort of resembles the idea. And the most intuitive way I can think about it going forward is you need a large count of zeros, which is totally possible given the data that we already know that like some days you're just not going to sell garden shears, right? Or some days you have like a stock out, right? So you have this huge count here, and then the rest of it follows like a sort of like Poisson or gamma distribution. So looking at some of the results, so Yeon Jun ended up winning with a score of 5.52043. And here's where I'm open to I'll try to open it up a little bit more. So the main issue is like this competition just finished like less than 2 months ago. So there's no public code on his solution. Everyone just did like a discussion post on what they did. And they claimed that they would add their code later, but I haven't been able to find it at this current moment. So what he did was he pre-processed like with price features, calendar features, time lag features, target rolling features. And then that's where he came up, like he began to like implement the recursive, non-recursive strategy. And then he began to model it by either like store ID, category ID, department ID, and then he stacked it. Now, I think he stacked the most popular model of the 3 on top of each other and then used that as like an ensemble for his final model. However, I'm not like 100% sure on that. It was kind of not very descriptive in his like discussion post. So looking at his results, he did like his 3 cross validations. He compared like the recursive versus the non-recursive strategy. He's tried to group it by store, by department, and compare it. And then this here is what makes me think that he began to stack it into one final model to produce the final outcome of it. And additionally, there was the fourth place solution, which kind of gives you like a little more idea of like what type of features people were looking at. So they looked at like sometimes like a sales lag or like a rolling mean, like a rolling standard deviation release. And then he began to do weekly models instead for each of the 10 stores. So he did like 40 models total. And that's about it. Is there any questions I can help answer?
I have a question.
Yeah, for sure.
Maybe I missed this, but so you said the top solution had like 0.52 or whatever score?
Yes.
But earlier you mentioned something about a really baseline model having like 0.75. So
yes.
what was the difference between? Like,
so
they didn't reach that, or?
Oh, you want smaller, right? You're trying to get closer to zero.
Oh.
Other way.
Okay. I was like, why is that one better?
Sorry,
okay.
You're trying to minimize the error, right?
I hope I wasn't the only one with that question.
No, I should have clarified. My apologies.
And while we're on the that kernel that you said was like you think kind of changed the arc of the competition.
Yes.
What was it score?
It was
0.47, I think.
Yeah, and then he did very poorly on the private.
Oh.
He got like 0.5, like just like it wasn't good. It ended up being good on his part. So I think like the real difference was like the feature engineering that people began to do, or introducing that like recursive versus like non-recursive idea and like experimenting with that.
I have a general question on LightGBM model.
Yes.
I think you mentioned earlier that this model works on a large scale of data.
Yes.
I was wondering if it also works on a big data as well.
I believe it does. I haven't had experience using it on big data. Has anyone like had an opportunity to try it out?
There are gradient boosted tree algorithms, like in general, that work on, say, like Spark. That would be very similar to this.
Yeah.
It just involves like LightGBM's improvements involve like Quantel sketching and stuff like that make it a little bit faster. But I don't know if it actually gets that much faster when you have like a big data context and you're just like sending out tons of workers. I'll go check it out.
Thank you very much. Thanks.
Tom,
Hello.
So the data is a daily sales thing, right? And
yes.
You talked about rolling averages a bit. I might have missed this, but did you add features like rolling averages, or was that just part of your EDA?
That was just part of my EDA, right? Like I just more like introduced that idea to like kind of to show that like this is like a business. It does follow like cyclical businesses problems, right? Of like higher sales in like the winter, Christmas time, and lower sales. Mm-hmm. But like as we can see, like a couple people did choose to use like the first place seemed to use like a target lag feature, which he didn't clarify exactly what he meant by that, or like a rolling feature, and no one really asked in the comments below. So they are taking advantage of those like rolling features though.
Going back a slide, I think you had a moment ago.
Yes.
Here, so that column that's full of green numbers, big green numbers. So that's interesting. That's not exactly typical. So that means that all of these top 10 performers, for the most part, had very bad public leaderboard scores. Well, do you know what's going on there?
That's a good question. I think it just comes down to a little bit of like the randomness of this problem in general, right? Where you can create like a model that just happens to work in like a given month.
If you look at the public leaderboard, there's like a ton of people that have 0 on it.
Yeah.
So I think that they probably just like, they had access to the data and just submitted that, and then they thought they were being clever. Like I top 50 for sure. Let me see how far it goes. So that's like a big part of it. I think the other part of it in like the winning solution, I think what probably actually won it for them, because it's not like compared to that fourth place solution, which was like 50 models or whatever, this was just 6. But their way of doing cross validation, I think, was like very good and pretty astute by not including stuff that was beyond like a year, so that the model would just look at like, oh, what was like a year ago, like,
Like additionally, they did say that they did want to freeze the public leaderboard, but I guess something leaked and people got in submissions before that, like after that. Sorry.
Yeah, that's what it looks like. So the first 715 places are at 0 error. So that is definitely a data leak, and there's a ton more that are like obviously data leaks as well, because it's like 0.02.
Okay, so it's just Kaggle was just broken, basically. Yeah, okay. This stacking is interesting. Was there any like a comment about the combination? So, like I have
this one.
Yeah, so I guess I have 6 models that I could each use to make. Well, actually, not 6. Sort of 18, right? Like I for each row in the upper table, I train a model on each of the folds, and then if I'm this guy, I also train it on the public leaderboard data when it's released.
Mm-hmm.
So I guess that's actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 4, 40 models, and I could use each of those to make a prediction. Ultimately, on the final test data, it's interesting. Like I wonder, like when you use the word stacking, you suggest that you do more than just like take the average or something.
Yeah.
He hasn't disclosed that much, I guess.
No, he didn't. He didn't just like. It's just like one post, right? And then he would like answer some questions. Like so. A lot of the questions kind of like aligned with like, why did you use like LightGBM, or why did you do recursive versus non-recursive, right? And then him linking off people to like different whatchamacallit, like different like notebooks or discussion posts where people were like discussing like why you would want to do it a certain way.
Okay, and then so my interpretation of this diagram, for example, with this, like the row of model by store ID, like, so my interpretation of that is that they trained, I guess, sorry, there were 8 stores, so they trained 8 different models, and the model was kind of agnostic as towards like what exactly the item was.
Like on this one?
So yeah, like it just helped me. What do you suppose recursive by store means? What do you think the by store part of that means?
I think he began to just more think of it as like a store level and tried to predict like the store items, and then maybe he tried to divide it out and like just divide that out by how many like SKUs there were to make it average out. That's just my interpretation of it. Everyone kept talking about like grouping by like store or grouping by like non-recursive one, and I couldn't really find like information on what they meant by grouping.
Okay. Interesting. Go ahead, Matt.
I think it might just be like how you choose to do the rolling average could be like individually by store or across all stores.
An observation on this slide is that the non-recursive models, the bold number is always CV3, and for the recursive models, the bold number is always public. That is a very interesting situation, right? Like these are 2 dramatically different forecasting methods that performed best in these particular windows reliably.
I was wondering about Konstantin, the guy who did LightGBM first. I thought private data only precedes public data only precedes the private data by 28 days. What makes it? What happened in the 28 days that made his model perform so much worse? Is there any idea?
I don't know if this like 3 shades darker answer that he provided was definitely like he didn't do like it doesn't seem like he was doing very much in the way of like feature engineering or choosing how to do his like cross validation, for example. So that might have made the difference in the last 28 days. That's my like intuition on it. I was shocked that like how low his score actually was when we end up clicking on it. And I can see people felt really bad because everyone like would thank him in their winning solution.
Yeah.
So I guess people were also like really shocked about it, right?
And I was just surprised that the winning solutions were all worse than his solution at this point with the public data. Mm-hmm. So
who knows? Maybe like there was also like a large amount of time where people were like entering the competition, and then you got like 23 days to make your final prediction on like the public side of it, right?
Yeah.
So maybe people are like very like hyper parameter tuning or like getting it to be like really specific for the public leaderboard, and then it wasn't like generalized. They couldn't like generalize it to the private leaderboard in like that short amount of time.
So I was curious about LightGBM. I am not very familiar with it, but is it? Do people just use the date as a predictor instead of treating it as time series data, or does LightGBM do time series?
I believe they're kind of treating it. Matt can correct me, but like I believe they're kind of okay. I'm not, no help from Matt. But I believe what people are kind of doing is like they're using it as like a way to like predict like a regressor, like they're treating it as like a regression problem.
Yeah.
And then you're trying to predict like that many days in advance, right?
Thank you.
Yeah, like you encode the time series like as features in such a way that like you take all of the history and they all become just this flat collection of data points.
Mm-hmm.
Yeah, that's what all the feature engineering is doing.
Yeah.
All right. So
go ahead.
Yeah, so yeah, that was actually why I was wondering why it doesn't seem to be like a classic time series forecasting, because I was wondering like if there was any treatment done to like, seasonal or trend effect. But if that's the case, then it totally makes sense now. Yeah. So basically it's using feature engineering to transform blocks of the data into, just features for that particular instance and discard the date altogether, right?
Mm-hmm. Yeah. So I think that's why they kind of did it as that ID, like just like day, like for like day, which like day like 1832 or something, right? Like there was no like a date associated. Like there was like a date associated with, but you weren't including that into your model, right? You could for sure like include that it was like a Monday though, or encode like there was like a Monday. That day happened to be like a Monday, or this day happened to be like a Tuesday.
Yeah, right. Yeah.
I imagine you're doing that as well for months and possibly the day of the month as well. So
and holidays as well is a really common thing.
Yeah.
And like that information was like all provided for you, right? Like if just like see like what day of like a holiday it was, right? And see if that like would change it at all.
Yeah, so like the most naive thing I could do is say, like, I want to predict tomorrow based on the last 28 days. And so what I do is I go through all of my 40,000 time series and I just slide this window across the time series, and every possible chunk of 28 days, I cut it out, and then I take the 29th day and I say, that's the target. And then I just stack them up. And so then I just have this like million long stack of 28 numbers. And then I have a million long of 1. And then I can sort of pass it to this sort of time agnostic model like LightGBM, and then train it to do this like from these are lags essentially, right? Like the lag of this item. And then like that would be like the most naive way of transforming the data. And then of course you could do like much better things.
Mm-hmm. That's what we were taught to do, like that sort of like naive like lag thing as like a first step. And I guess like when you look at solution 4, there is definitely some type of lag for like a sales lag. Looks like they actually went to like a lag of 14 days, which is interesting.
Yeah, like so often like the best forecast for tomorrow is whatever the number from today was, right? And that's like a great baseline, and then struggle to do better.
I'm sorry, I wish I included that like lag idea as like a feature in like my presentation.
Yeah, I mean like the rolling means and stuff. It's like all just different ways of computing sort of time invariant. No, that's not the right term. But anyways, yeah, features that you can then use to sort of flatten the world into a giant matrix, right? Because like that's modern machine learning. All we really want to do is somehow manipulate this into a giant matrix.
Yeah, for sure. I also like how like the fourth one also kind of you decided to use like price with like what is its max, what is its mean, what is its current kind of thing. Because like I guess like the idea is like if it's beginning to like drop down, then it's going to sell more. Like they're trying to move that kind of object.
I found something kind of interesting in this 3 Shades of Darker Magic notebook that could explain some of the overfitting. So when I'm looking at the parameters that were used in the LightGBM model, the number of leaves that was put in, which is the maximum number of leaves that each individual tree can have in this algorithm, is 2 to the 11, where the normal amount, or like the default, is like 30 or 50.
Right.
Now, the idea behind LightGBM is you have a bunch of weak estimators kind of like averaged together. Well, not average, but they all kind of come together. But if you have a ton of very strong estimators, you're going to overfit like crazy. So if the other people change that number around, that would probably be better for them if they went for like a weaker number of leaves. I'm actually really curious why they would make it so high. So the min number of data in each leaf is also 2 to the power of 12 minus 1, which is an extremely high amount. So it seems like that would overfit like crazy, but I had never seen something like that before.
Mm-hmm.
But to be clear, like when he created that kernel and it got the score it did on the public leaderboard, like that was generalizing, right? Like that was training on data that was like not in that time window and then performing well on data that was in that time window. So even if it was overfitting, it was generalizing to a good score, right?
Yeah, it just might not have generalized very well to the private leaderboard. Like
somehow
some
it really matters.
Yeah, like that would be my guess just looking at it, because it seems so far from what the norm would be.
Additionally, I didn't. Everyone also made it a point to say that they didn't use any early stop, like no early stopping. So that's like letting it go all the way down and trying its possibilities, right?
Yeah. Do you know like roughly the order of magnitude of, let's say, resources that people required for this? Like, how much time was it taking to train a single model on like what sort of a machine, or like even just like the raw data? I guess it probably wasn't huge, but sometimes with enough data processing, you might end up needing an awful lot of RAM.
Mm-hmm.
Do you know what like the runtime of that one kernel was, for example?
Hey, Matt, if you have it open, I think it was.
I do. Yeah.
I think it was a couple of hours.
Yeah. So, like at the start of it, they just start by predicting day one, which took like 3 minutes, but they have to do it for every single day. And then for day 28, it takes 91 minutes to train.
Because there's more features for that day, I guess.
Yeah, I think it's like rolling up, right? And like you can have more leg features, and that's what's happening, I would guess.
Did they, did they try to explore, other day window options like shorter or longer than 28 days? Because, it's like 28 days, like, a requirement for this?
Like for prediction or for your cross validation? Like what you're training on or what you're predicting?
Prediction.
Oh, that'd be interesting. I think you want to probably stop yourself at like day 28 just because it becomes like infinitely harder to predict day 29, and it just becomes like a wasting your like resources and time.
Mm-hmm.
Like, cause like again, like the further you get like out from further you're trying to predict, the less accurate and more randomness typically is involved in that, right?
Right.
And I don't think it affects your day 27. Like if you know what day, if you predict day 29, it doesn't affect what you know on day 27, right?
Uh-huh. Okay, yeah.
Sorry, I have thank you very much for the presentation, by the way. I really enjoyed it.
Thank you.
I have a questions actually on the way that test and then train data set was split and in a different sequence. I think you touched base on this during your presentation, but I wanted to understand like how this will impact optimizing the result using LightGBM.
Yeah, so I think it like typically you can make these cross validations at any point you want, really, right? So typically what people do at the very beginning is they'll just say like, I want 3 cross validations, here's all my data, and then it like chops it in certain sections and then does this training idea, right? This graphic is actually from like a Uber presentation that someone did, and it doesn't line up exactly what they did on the competition. So for example, you can see that they're training and then predicting on like a little bit forward and then cutting like a little bit back, where in reality, these bars should be here. And then like these bars should not like overlap at all, right? Like this one should be like brought out to here and then turned orange, right?
Okay.
I'm not sure I would agree with that, but also, Matt, you said something interesting about cross-validation earlier, where you thought some differences in scores could be due to different approaches to cross-validation, but it was kind of a side comment. I was wondering if you know a bit more about that.
This is only speculation, but like usually when I see someone who does really well on public leaderboard and then they kind of bomb the private leaderboard, it's because they have done something to their validation, which at the time seemed smart, but in the end probably like didn't work out for them. What I think is particularly clever about this method, right, which isn't the exact same method, is one, it limits the amount of features that are going to be made, right? So if you take like all of the data and you do like leg features for all of like the possible, like essentially you have like the number of features is going to be like some like O of n squared based off of the number of days that you have, right? Which is like way too many, especially because like, is there anything that you're going to get out of like, well, what were things like 57 days ago that you didn't get in the previous 56 days? Just kind of thinking about that. But like, what I particularly like about this sort of method here is it's trying to like, not remove, but it's trying to like partition these, the cross-validation, right? There is a little bit of overlap in this image, but it sounds like the way that it was actually done, there was no overlap, very little overlap.
I don't think there was like overlap. Like once the data was trained on the model, it was brought to the next day, right?
Exactly. So because there was very little overlap or no overlap, let's just say no overlap, that means that you're getting a much better estimation of how good the algorithm actually is versus if you do what I've seen like a lot of people do in kind of time series stuff where they look at the same data over and over again, but they're predicting like a different time point each time. Then like it's very easy to get caught overfitting. And I think that's probably what happened with some other people here. I'm still looking through that original like darker notebook. But yeah, like I think like a principled like time series cross-validation will get you really far. I think it's just hard to do it right.
Sorry, I'm not quite understanding. If I want to predict, let's say, upcoming Sunday, and I'm training on the 28 days prior to that Sunday, right? And then I want to predict Monday as well. Am I not training on an overlap of 27 days because I'm moving one forward, including the prediction for Sunday?
So it would be fine for you to predict both Sunday and Monday from that amount of data, but you wouldn't want to call that a separate, like the Sunday and the Monday prediction are not separate folds, right? They're within the same fold. You're predicting multiple things, right? So if you want to have multiple folds, in this case, what you have to do is like say, okay, everything in this 3-month period, that's one fold. Everything in this other 3-month period, that's the next fold, et cetera, et cetera. You can't have like, okay, well, everything from March to June is one fold, and then everything from April to July is a different fold, right? Because you have that overlap of April to whatever I said, June. That is the same amount of data, and then you just may happen to get like algorithms that are going to say, oh, well, there's something really interesting inside of, April that I'm able to find, but I can't find it anywhere else. So does that explain it? Does that help?
Matt.
Yep.
Hi. Can I also because I'm also not clear on this, so I'm just reading the lines in red. So pass one says from day 1830 to day 1857, and then pass two says day 1858 to 1885. So that's the validation set, right? So it seems that for the training set, there is indeed some overlapping.
Tim, in the Thomas, sorry, Jesus Christ.
No worries.
In the solution, it said that there was an overlap. Is that correct? It's just in the way that like this different visualization, it makes it look like there is. Is that correct?
From what I can gather, it doesn't look like there was overlap because he just said his cross-validation days, right? Like he didn't say no overlap. He didn't like clarify either way. From what like my understanding of it, there was no overlap. However, I can see that this is now like a point of like debate. I didn't expect it to be.
There's no overlap, right? He gave the date.
But how many days before the validation you are using? Say the period for validation is 28 days. It seems that the training set has more days than the validation set, so which means
yeah, no, I think that's just like so you could, if you wanted to train your data and create your cross validation, you could go all the way back to day one. But he chose not to do that. He chose to start only 3 months in advance, or 3 months behind.
3 months. Yeah. So if you look at the CV2, right? So CV2 has days 1858 to 1885, and then CV1 has 1830 to 1857, and then if the training set is like is 3 months, like 3 months back, which means in pass 1 and pass 2, the training set will have some overlapping.
Oh, I see what you're saying. You're trying to, okay, I got what you're trying to say. You're trying to say it's also, they haven't cut CV1, they've just continued forward.
Because the end of I guess maybe the later 70% of CV1 will also in pass 1 will also be used for pass 2. So
you know what, I'll dig a little bit more into this after this presentation, and I'll send like an update on it. How about that? I think that's like the best thing to do at this point.
I just couldn't understand this. So
yeah. And it probably doesn't help that I'm using like a graphic that doesn't necessarily belong with this solution, right?
Yeah.
I was just going to go ahead. This is better. Go ahead.
Sorry. Just I guess this could be a very quick answer actually. On that same slide, actually, is there a logic for the data that was dropped for phase 2 and pass 2 and pass 3?
So, like, when you design your cross validation, like what you want to do is you want to create a framework under which you can make empirical decisions about what works better and what doesn't work as well, and you try to avoid like sampling error, where like you don't want to try method A and method B and just have it just be that like method B was worse, but like spuriously it just got a higher score, right? Like because there's just randomness in the world, and so like when you're, so this is why earlier when I said like this choice this person made about just these 3 splits with these 3 measurement windows is that like what happened in those months, like if something weird happened in those months, then you might be making a bunch of wrong choices. But anyways, to get to your question, like if you let yourself go back to day 0, which is not an unreasonable thing to do, it does mean that for some of your splits you have more training data, right? Like if on the left-hand side of this diagram, if we take the dark gray bars and we extend them all the way to the left so they eat the light gray bars, like we're expecting the phase 3 model to just be better than probably because it had more data. And the one thing we know for sure about machine learning is if you have more data, you do better. And so then like we're more like models for phase 3 are more likely to be better, and therefore they're more likely to get higher scores on the gold bar in phase 3, and therefore if we're trying to make decisions about whether method A or method B is better, like we're kind of more biased towards something that does well on that one window for phase 3, and that like might be a reason to sort of to hesitate and to think that you want to make all of these things more even so that your like empirical measurement of the performance of A and B is kind of more cleanly measured so that you can make your choice.
Thank you. Thanks.
On another topic, so I was just digging through the Kaggle stuff. So the solution, I think it's the right thing to do to focus on LightGBM in this presentation because it's top performers used it and it's what a practitioner should use. Interestingly, though, the third place solution did use a neural network.
Yes, they did.
And they actually used recurrent neural networks. So it was LSTMs. In their summary here, they specifically say that they tried transformers and CNNs and they weren't better, which I think is very interesting because we live in the age of the LSTM being dead, and this seems like a problem that you could effectively apply attention to. That doesn't seem like that would be hard. And yeah, so they say they use a bunch of LSTMs. Interestingly, they used what they called Tweedie loss, which tickles me. That's the kind of thing Kaggle would do. So they somehow hacked together a loss that respects this Tweedie distribution, which is, it's great. Obviously it worked. So that's very interesting also.
From the discussion forums, it sounded like I didn't really dig deep enough into it because neural networks aren't really my thing. But I heard it you could probably do a whole presentation just based off the one notebook, and there's a lot to be learned from it.
And I think there might be this is kind of inside baseball, as in it's a little bit too Kaggle-y, but there's a throwaway comment in the description of the number one solution. So in the diagram there from the thing, they say without post-processing, right?
Mm-hmm.
So why do you suppose that's written there? Well, lower down, I see this line that says, no magic numbers, no magic scaling numbers or something. Now I'm trying to remember where I found it exactly. Or no, maybe it wasn't theirs. Maybe it was the neural network one. So something tells me that people because there's a great way to overfit, right? What you do is you make a model for the public leaderboard and you get some score. And then you're like, what if I just, had one more parameter in my model, which was I multiplied all my predictions by 1.1. Would that improve my score? Oh, it did improve my score. Huh. What if it were 1.2? Oh, that was also an improvement. What about 1.3? Oh, that wasn't. Well, I guess we'll go with 1.2. This is a great submission. But of course that, you don't get to play that game with the private leaderboard.
Yeah.
And I wouldn't be surprised if something like that was going on here.
I'm gonna be honest, I've never tried a magic number like that.
Oh, you see that in Kaggle for sure.
Oh, you do for sure.
Yeah, at the end of the notebook.
It's a bad idea.
At the end of the notebook, there's just this hard-coded number. Comment, score goes up when I do this.
I remember this was a long time ago, but I remember people used to optimize for random seed values and stuff like that. It's there's no possible way that would actually work.
But we all know the best seed number is 42.
Yeah.
I agree completely. Sometimes 42.0. We are running up on time.
Is there any other questions I can potentially try to answer?
Well, I'll bookend the recording here, but then when people think of those questions, we can just kind of continue on.
For sure.
So to conclude the recording, so thank you very much, Thomas, for this good presentation. I think I encourage the audience to study this example and to be inspired to be presenters themselves. And please do get in touch if you are inspired to do so. And then finally, we have a very cute and awkward COVID era tradition of attempting to give a round of applause to our presenters. And so what I'm going to do is I'm going to count down from 7, and I'm going to encourage people to unmute themselves and for us to do a little round of applause. So we'll see how that works. I'm going to go down from 7, 6, 5, 4, 3, 2, 1. Yay! I think that's just me clapping and you clapping for yourself. That's embarrassing. No. Okay, so that's a wrap. Please feel free to stick around and to ask more questions or debate more, but that respects our time slot.
For sure. Thank you very much for having me and letting me present today. It was a lot of fun.